Did you know that every day around 100 tons of space dust falls on Earth? That's right, 100 tons. We're constantly being showered by a cosmic waterfall even though we can't see it. This isn't just any ordinary dust, this is space dust, a remarkable substance that's as fascinating as it is ubiquitous. It's everywhere in the universe, from the vast voids between galaxies to the air we breathe here on Earth. And it's not just a byproduct of cosmic activities. It's a vital part of the life cycle of the universe. Space dust is like the universe's DNA. It contains the building blocks of stars, planets, and possibly even life itself. It's born in the fiery depths of stars, blasted into space by supernovae, and carried across the cosmos by stellar winds. It's these tiny particles that seed the universe with the elements necessary for life. But the story of space dust doesn't end there. It also plays a crucial role in the formation of celestial bodies. It's the glue that holds galaxies together, the raw material for new stars, and the seeds from which planets grow. It's even responsible for the beautiful tails of comets that streak across our night sky. Here on Earth, we're constantly under the influence of space dust. It falls on our heads, it's in the air we breathe, and it's even found its way into our oceans. It's an alien substance, yet it's as much a part of our world as the ground beneath our feet. Space dust is more than just a curiosity. It's a window into the history of the universe, a key to understanding how our world came to be, and potentially a tool for exploring the cosmos. Scientists are just beginning to uncover its secrets, and what they're finding is reshaping our understanding of the universe. So, the next time you're out under the stars, remember, you're standing under a cosmic waterfall. Imagine a nursery of stars, all birthed from the same material, space dust. Space dust, the unsung hero of our cosmos, is more than just tiny particles floating aimlessly in the void. It plays an integral role in the birth of stars, acting as the fundamental building blocks in stellar nurseries. In the vast expanse of the universe, these particles begin to cluster together, drawn by their mutual gravitational pull. Over millions of years, these clusters grow denser and denser, forming a cosmic cloud of gas and dust known as a nebula. As gravity continues to pull the particles closer, the center of the nebula grows hotter and denser, until finally, a new star ignites in a brilliant burst of nuclear fusion. Each star we see in the night sky, including our own sun, was once nothing more than a cloud of space dust. These stellar nurseries are the universe's factories, constantly churning out new stars from the seemingly insignificant particles that make up space dust. But the story doesn't end there. As stars age and eventually explode in spectacular supernovae, they scatter their enriched material back into space, contributing to the cycle of star birth and death. This cosmic dust then goes on to form new stars, planets, and possibly even life. In the great cosmic dance, space dust leads the first step. Ever wonder how planets are formed? The answer lies in space dust. Let's take a journey back in time to when our solar system was just a swirling cloud of gas and dust. This dust, microscopic and plentiful, is the building block of planets. It's almost like a cosmic Lego set. Gravity, the unseen puppet master of the universe, starts to pull these tiny particles together. Picture a dance, where each dust particle is drawn to another, merging, growing, forming clumps. Over time, these clumps grow larger and larger, their gravitational pull becoming stronger with each addition. Before we know it, these clumps transform into planetesimals, the precursors to planets. These planetesimals continue to collide and coalesce, growing in size until they become protoplanets. The protoplanets, still not quite planets, keep on attracting more and more dust and gas. Eventually, they reach a point where their gravity is strong enough to pull in even more material, forming a spherical shape. This, my friends, is the birth of a planet. But it doesn't stop there. Even after a planet is fully formed, space dust continues to play a part, contributing to the planet's atmosphere, and even perhaps bringing water and organic materials necessary for life. This process, from dust to planet, takes millions, if not billions of years. It's a slow dance, choreographed by the laws of physics and gravity. From tiny grains to massive spheres, space dust shapes our planets. The beautiful tails of comets? Thanks space dust for that. You see, these celestial spectacles owe their mesmerizing trails to the very thing we're exploring today, space dust. When a comet travels through the solar system, it leaves behind a path of dust particles, creating what we know as a comet's tail. Now, you might be wondering, how do we even see this dust from our humble abode here on Earth? Well, it's all thanks to our very own star, the Sun. As sunlight hits these dust particles, it reflects off them and travels all the way to us, making these tails visible and awe-inspiring. So, the next time you marvel at a comet streaking across the night sky, remember it's not just a lone rock speeding through space. It's a cosmic voyager trailed by a magnificent tail of space dust illuminated by the sun. Remember, every comet tail is a testament to the ubiquity of space dust. Space dust could be the reason we have water on Earth. A fascinating concept, isn't it? The idea that the life-giving substance we so often take for granted could have such an extraordinary origin. Let's delve into the theories that suggest this intriguing possibility. Imagine the early solar system, a swirling mass of dust and gas. Among this cosmic chaos, tiny particles of dust are colliding and sticking together, gradually forming larger and larger bodies. Some of these bodies become what we know as comets. Now picture these comets, icy wanderers journeying through the solar system. Their icy composition is primarily water, frozen in the depths of space. These icy travelers have long been considered a potential source of Earth's water. As they orbit the sun, their outer layers vaporize, creating a glowing envelope of gas and dust, a tail that stretches millions of kilometers across the cosmos. But how does this water get from a comet to our planet? The answer lies in the comet's tail. As Earth passes through this tail, the water vapor and dust particles settle on our planet's surface. Over billions of years, these tiny contributions could accumulate, forming the vast oceans we see today. This theory, while still under scientific scrutiny, offers a tantalizing glimpse into the cosmic origins of our planet's water. So the next time you quench your thirst, remember, every sip of water might just have a cosmic origin. Space dust isn't just inorganic, it carries life's building blocks too. Now let's take a moment to think about that. This seemingly insignificant dust floating around in the vast expanse of the cosmos could potentially be the reason life exists as we know it. But how is that possible? Well, space dust is more than just tiny particles of rock and mineral. It also carries organic materials, complex molecules containing carbon, hydrogen, oxygen, and nitrogen. These are the same elements that form amino acids, the building blocks of proteins, which are essential for life. If you're wondering where these organic materials come from, think of stars. When stars die, they explode, casting off dust and gas, including these organic materials. This stellar dust then travels through space, potentially seeding other planets with these life-essential ingredients. Imagine the journey of a single dust particle, born in the fiery death of a star, traveling through the cosmos for billions of years before finally landing on a planet. It's a tale of cosmic proportions, a story of how life's essential elements may have traveled across the universe. But there's more. Researchers have found traces of these organic materials in the dust that has made its way to Earth. This suggests that our own planet may have been seeded in this way, with the ingredients for life delivered by space dust. Life as we know it might owe a debt to space dust. It's a humbling thought, isn't it? That the secrets of our existence could be hidden in something as simple and as complex as dust. Our Milky Way is a dusty place, but it's not alone. Every galaxy we gaze upon, from the pinwheel spirals to the distant ellipticals, all of them carry the mark of space dust. This dust, a seemingly insignificant player in the cosmic theater, is actually a fundamental part of a galaxy's formation and evolution. In the grand cosmic dance, dust particles swirl and twirl, eventually clumping together to form the building blocks of stars, planets, and even galaxies themselves. These dust particles, born from the life cycles of stars, become the seeds from which new celestial bodies grow. Imagine a galaxy as a cosmic garden where space dust is the soil nurturing the birth of stars and planets. But it's not just about birth and formation. The role of space dust in the universe extends to the grand spectacle we witness when we look up at the night sky. Those mesmerizing images of galaxies, with their vibrant colors and intricate patterns, are all thanks to space dust. It scatters and absorbs light, creating the breathtaking cosmic images that leave us in awe. The dust gives galaxies their unique glow and their distinctive silhouettes. So the next time you find yourself marveling at the beauty of a distant galaxy, remember the humble space dust. It's more than just a cosmic nuisance. It's an essential element in the grand design of the universe. Space dust is the unsung hero of our galaxy's beauty. Space dust isn't always a friend to our technology. This seemingly insignificant cosmic fluff can actually pose significant challenges to our space exploration efforts and satellite technology. Imagine, if you will, a microscopic particle of dust whizzing through space at incredible speeds. Colliding with our spacecraft, this small particle can cause substantial damage. This is what we call micrometeoroid bombardment, a constant risk for our spacefaring technology. The dust specks can pit and erode the surfaces of satellites, space probes, and even the International Space Station. They can interfere with optical systems, clog filters, and damage sensitive electronics. But don't despair. We're not helpless against these tiny cosmic assailants. Our brilliant scientists and engineers have devised ways to protect our technology. For instance, they use materials with self-healing properties or add layers of Kevlar for protection. They also design spacecraft systems to be redundant, so if one part is damaged, another can take over. In addition, we're also developing ways to predict and track dust storms on other planets like Mars to safeguard our rovers and landers. The Mars Climate Sounder on board the Mars Reconnaissance Orbiter, for example, helps us forecast Martian weather. Despite these challenges, space dust does offer potential technological benefits too. It's a possible source of in-space manufacturing materials or even fuel for future spacecraft. In the space race, dust is a formidable contender. But as we push the boundaries of human knowledge and capabilities, we continue to find innovative ways to turn these challenges into opportunities. Studying space dust is like reading the universe's diary. Imagine scientists as detectives sifting through clues to uncover the mysteries of the cosmos. Their magnifying glass, sophisticated instruments aboard spacecraft like NASA's Stardust mission, which collected samples of interstellar dust particles and returned them to Earth for analysis. So how do they decipher these infinitesimal specks of matter? They employ a range of techniques, from spectral analysis, which identifies the chemical makeup of the dust by the way it absorbs or emits light, to electron microscopy, which reveals the detailed structure of these particles. But space dust doesn't just tell us what it's made of, it's also a time capsule, capturing a moment in the universe's history. By studying the isotopic composition of these particles, scientists can determine their age and origin. Some dust grains predate our solar system, offering insights into the nuclear reactions in ancient stars that gave birth to the elements we know today. Furthermore, by observing how dust interacts with light, we can trace the shape and evolution of galaxies and the distribution of dark matter, the elusive substance that makes up over 80% of the universe's mass. These studies also give us clues about the building blocks of life. Some space dust contains complex organic molecules, suggesting that the seeds for life may be widespread throughout the cosmos. Space dust holds the secrets of the cosmos, and we're just beginning to read them. With new technology, we're uncovering more about space dust than ever before. As we peer into the cosmic dust clouds, we're not just looking at specks of matter, we're delving into the origins of our universe and the building blocks of life. In the future, space dust research is poised to take giant leaps forward. Planned missions, such as NASA's Interstellar Mapping and Acceleration Probe, aim to study the interstellar medium and its dust in unprecedented detail. Other prospective missions could even bring samples of space dust back to Earth, allowing scientists to examine these cosmic particles under the microscope. These initiatives promise to not only deepen our understanding of space dust, but also shed light on broader cosmic questions like the process of star and planet formation, the evolution of galaxies, and possibly even the origins of life itself. As we continue to unravel the mysteries of space dust, who knows what we'll discover next? From the birth of stars to the formation of planets, space dust plays a fundamental role in the universe. It's an unseen world that holds the keys to our understanding of the cosmos. We've journeyed through the birth of stars, where space dust acts as the building blocks of these celestial bodies. We've witnessed the creation of planets, sculpted and formed from this very dust. We've explored the enchanting tales of comets, made visible by the reflective properties of space dust. We've delved into the fascinating role of space dust in delivering water and organic materials to our own planet. We've discovered how galaxies, those vast cosmic communities, are teeming with dust. We've seen how technology is influenced by space dust and how we're studying this cosmic phenomenon to unlock future possibilities. So remember, the next time you look up at the night sky, there's more than just stars and planets. There's a universe of dust. Incredible, isn't it? The universe we inhabit is filled with wonders we are just beginning to understand. If you've learned something new from this journey through the dusty universe, please give this video a like. We'd love to hear your thoughts and opinions in the comments section below. Engage with us, share your theories, or just marvel at the wonders of the cosmos. Don't forget to subscribe to our channel and press the bell icon for more fascinating insights into the universe. Our exploration of the cosmos is a shared journey, so feel free to share this video with your friends and family. Let's dive deeper into the mysteries of the universe together. Until then, keep looking up and remember, it's not just space, it's a universe of dust.